Hello students, welcome to another interesting lesson. In this lesson, we'll be learning on latitude and longitude. Latitude is a measurement on a globe or map of location north or south of the equator. You can see the picture. While longitude is a measurement of location east or west of the prime meridian at Greenwich. This specifically designated imagery north-south line passes through both geographic poles. Let's invite our scientist Leon to hear more about longitude and latitude.
In this lesson, we're going to be talking about a system that will help us describe a position on the surface of the Earth. As we know, the Earth is a really big place, and it's really hard to describe a location on the Earth without getting into too much detail. What we really need is a system that will accurately describe our location so that others can know where we are. Scientists have come up with a way to describe your location on the surface of the Earth, and it's very similar to a system you're probably already familiar with from math class. This system has a x and a y-axis, where the x-axis describes how far right or left we are, and the y-axis describes how far up or down we are. Today, we're going to be talking about two new terms, which is latitude and longitude. Latitude describes how far up or down we are on the surface of the Earth, or north or south, while longitude describes how far right or left we are on the surface of the Earth, or east and west. The first system we're going to talk about is the system of latitude. And just like any other system, we need a starting point, a location where we can base all other locations off of. This location is known as 0 degrees and is also known as the equator. Now, if you were to imagine making a 90-degree angle with this equatorial line, you'd be pointing at a location that is 90 degrees away from the equator. This location is known as 90 degrees north and is sometimes called the North Pole. If you did this for every other location on the Earth, you'd eventually get a series of numbers that represent a very specific location north or south of the equator. So as you moved north or south from 0 degrees, you'd eventually hit 30 degrees north or 30 degrees south. You'd eventually hit 60 degrees north or 60 degrees south, and finally you'd get to the poles, 90 degrees north and 90 degrees south. Now, the latitude system can be very accurate describing your location, north or south of the equator. This X represents our location here in New York State, and we can use our position to give a very exact numerical value for our latitude. If we were to draw a line directly horizontal going through that X, we would find that we're at a latitude that is very close to 41 degrees north. 41 degrees north turns out to be our latitude here on Long Island. We can do this for any other location on the Earth to describe how far north or south we are from the equator. Now, the system of latitude has a couple very important latitudes that are really based off of the system of the Sun and the Earth. Now, these numbers are also given special names that are very important, and you're going to have to memorize and be familiar with as we go on throughout the year. So you already know the first one, which is 0 degrees, and it's called the equator. But as we move further from the equator, as we move north and south, we're eventually going to get to the tropics. And 23.5 degrees north is known as the Tropic of Cancer, while 23.5 degrees south is known as the Tropic of Capricorn. As we move further from the equator, we're eventually going to get to 66.5 degrees north, which is known as the Arctic Circle, and 66.5 degrees south, which is known as the Antarctic Circle. You should already know what 90 degrees north and south are. That is the North and South Pole. So just to summarize, to sum it all up, what is latitude? Well, latitude is our unit that is going to measure how far north or south we are from the equator. And lines of latitude are very distinct in that they're parallel to each other, meaning they never intersect, and they run east, west, or right and left. I like to remember it by saying lat is flat. All the lines of latitude are flat. Now, here in the northern hemisphere, we have a very easy way to determine our latitude, and it's based off of a star that's very important we're going to learn a lot about throughout the rest of the year. Our latitude is exactly equal to the altitude of Polaris, which is the North Star. And the altitude of Polaris can be determined by finding how far off the horizon Polaris is at a certain location. So here in this diagram to the right, we see that the observer is at 60 degrees north, and if he was to determine the altitude of Polaris at that location, the altitude of Polaris would be 60 degrees. So again, the altitude of Polaris for an observer is exactly equal to their latitude. So that is the latitude system, and it's overall a pretty easy system that describes simply how far north or south you are from the equator. But that's not going to give you an accurate location on the Earth, because there are many locations on the surface of the Earth that, for instance, could be found at 0 degrees. So we need a way to describe where we are right and left, or east and west, and that is the system of longitude. And again, we need a starting point. Now, unfortunately, there's no natural starting point for the system of longitude. There's no natural place where longitude can be started. And for this reason, the location of the starting point has changed over the course of history. Today, this location is known as the prime meridian, and it runs through Greenwich, England. And it, again, is known as 0 degrees longitude. Okay, so if we look a little bit closer, we can see that this line of longitude, 0 degrees, also known as the prime meridian, runs north-south and will help us measure east and west. Okay, so as I move west from the prime meridian, all of my values will be in the western hemisphere. If I move east from the prime meridian, all my values will be in the eastern hemisphere. So let's do a little bit of practice. Here we have a location at 45 degrees, and we need to be able to write this to describe to another person where we are on the surface of the Earth. It is not enough to say we are at 45 degrees. We also need to include a direction. In this case, we need to find the prime meridian, figure out which direction we need to go to get to our location, and that will help us determine what we put for the direction. So 45 degrees west is our location because we are moving west from the prime meridian. This new location, this new X, is also on the 45 degrees west line, and it shares the same longitude, even though they're in two separate locations. The only difference between them is their latitude, how far north or south they are. So you can see how two locations can share a longitude or share a latitude and still be in two separate locations. So what is longitude? Longitude measures how far you are east or west of the prime meridian. And all of these lines of longitude are known simply as meridians. They all meet at the poles, meaning they all intersect in two locations. So this is very different from the system of latitude where everything was parallel to each other. Now these meridians run from the north to the south, and they help us again measure east or west. So now that we have a system that'll help us describe locations on Earth, we can see that the Earth can be divided into separate areas based on the systems of latitude and longitude. If we look at the equator and we were to move north of that equator, all of that area can be described as being in the northern hemisphere. If we move south of the equator, all of that area would be described as being in the southern hemisphere. Pretty easy stuff. If we look at the prime meridian and we move east of the prime meridian, we can see that that location can be known as the eastern hemisphere. And if you were to move west of the prime meridian, that location would be described as being in the western hemisphere. So again, a very easy way to describe your location on the Earth using coordinates that are very similar to the XY system. So now that we understand some of the basics dealing with latitude and longitude, I figured it'd be pretty cool to take a look at Google Earth to try to get a more three-dimensional view of what's going on in this system. So here we're getting a pretty good view of the equator directly over what is basically Central America and northern South America. And we see that many of the ideas we learned in the beginning of the video are holding true on Google Earth. We're seeing lines of latitude running horizontally, all parallel to each other, and values increasing as we head further north from the equator. We're also seeing values increase as we head south from the equator. Now, dealing with longitude, we're seeing lines of longitude running north-south. They will help us measure east and west, and these lines of longitude will eventually meet up and intersect at both of the poles. Now, what I want to do is I want to travel to the point where the equator intersects the prime meridian. This location, if I were to write it down, is known as 0 degrees, 0 degrees. And we are going to learn how to describe the location of a position on Earth just by writing two very important coordinates. It could be thought of again like an XY coordinate. We're going to start off by looking at my hometown and figure out the XY or the latitude-longitude coordinates for this location. Now, as we travel to Westbury, New York, we can see that, first of all, its latitude is roughly between 30 degrees north and 50 degrees north. This line of latitude represents 40 degrees north, and it appears that Westbury is not directly on it. So I'm going to assume it's 41 degrees north. And we know from earlier in the video that 41 degrees north is the latitude of Long Island. So when writing the coordinates for a position on Earth, we first write the latitude. 41 degrees north is the latitude of Westbury, New York. I now need a longitude to complete my coordinates. I see that I have a 70 degree west longitude value here. I have a 90 degrees west line here, which means that this would equal 80 degrees, this line here. It looks like Westbury, New York is about halfway between 70 and 80. Not exactly, so I'm going to write 74. Now, it's not done there because I also need to include a direction. Well, to figure out the direction, I need to find out where my prime meridian is and figure out if I need to travel west or east from the prime meridian to get to my location. In this case, Westbury is in the western hemisphere, meaning I need to travel west from the prime meridian to get to it. So that means I am going to write W, which means west. So when reading the coordinates for Westbury, New York, I know that it is 41 degrees north and 74 degrees west. Let's practice with a second example. And my second example is a very famous location in Australia, made famous in the movie Finding Nemo, and that is the location of Sydney, Australia. Now we see here that Sydney, Australia is about 35 degrees south, and I know this because here's my line of latitude representing 30 degrees south. Here is 50 degrees south, which means this must be my 40 degrees south line, and it looks like this is right in the middle between 30 and 40. So I'm going to write 35 degrees south. Now again, that is not enough to give me an accurate location. I also need a longitude value, and I see that I have a longitude line representing 130 here. I have 140 here, and this would be my 150 degrees east line. And it looks like Sydney, Australia is directly on that line. How do I know, though, that it is in the eastern hemisphere? Well, again, I'm going to need to travel to the prime meridian and figure out which direction I need to travel to get to my location of Sydney, Australia. And again, here I am traveling to the east to get to Sydney, Australia. So when writing the longitude value for Sydney, Australia, I'm going to write 150 degrees east. So the location for Sydney, Australia is 35 degrees south, 100.
From this lesson, I'm sure we must have learnt about longitude and latitude, the great circles, the equator angles, and many more. Thank you for watching.